Okay, hello, I'm Christopher Carter, and this is your class about astronomy and telescopes and how they all work. And this is my telescope here. This is a Newtonian reflector. And I'm going to describe that process to you in just a minute. It's on a mount called a Dobsonian mount. What's normally underneath here, but I didn't put it on for the video, is a big circular base that the whole thing turns on down there. And then to make it go up and down, it turns on this axis here. So it's not an equatorial mount, it's called a Dobsonian mount because it has a real basic side to side and up down motion to it. Now, if you don't know a lot about telescopes, when I say it's a Newtonian reflector, what I mean is it's working with mirrors, not lenses. So if you look in here, and Ellen, if you put your camera down here, what you're going to see is only mirrors in this telescope. So there's no lenses anywhere. There's nothing to refract the light. There's only things to reflect it. So there's a big mirror down there, and that mirror is concave, so it's like a bowl. And what happens is the light comes in here, so we point the telescope, and this one gets pointed via a computer control. So I kind of align it with some stars and then tell it where I want it to go, and then it aligns itself, up or down and then left or right. And the light comes in here, goes all the way down to that mirror. And because it's a concave bowl, it reflects it back, but it doesn't reflect it the same way. So kind of point up here, Elle. When it reflects it, it starts to reflect it in a cone that's narrowing because that mirror is concave. So the light path starts to narrow like this. So then back down here, Elle. And so as that light is reflecting off the mirror and it's coming into a cone that's getting narrower and narrower, eventually it hits this right here, which is the secondary mirror. Now, Ellen, if you come around here and you look right in there, it's going to be bright. But that's the secondary mirror. Now, you're actually looking at the reflection of the primary.
Mirror right
There's
there.
the second. That's a great shot. So that light cone is just getting narrower and narrower until it hits that secondary, and it's still actually narrowing. So even though that's just a flat surface, the light path is still converging.
Okay.
So it's converging all the way through here, where my finger's going.
Okay.
It hits that 45-degree angle, goes through here, and then that light path comes out to where the eyepiece is. Now, a Newtonian reflector, as you can see, doesn't have the eyepiece where you think it goes on a telescope. A lot of telescopes are long and skinny, and the eyepiece is here and the end is down there. But a reflector uses this whole tube as the light path and then puts your eye at the top of the telescope. This is where the eyepiece goes here. We'll just get one out for fun.
Oh, you've got a lot, don't you?
Yeah, come on over here, Ellen. This is, so eyepieces are what gives the telescope different magnifications. So the larger the number, so this is a 30 millimeter eyepiece, that's the lower the magnification. So this gives me about 53 magnification. It's about as low as I can go comfortably. After that, actually, it's uncomfortable for your eye.
Which
This-
one do you use the most?
Well, that's a great question. So to start out when I'm looking for stuff, I like to use, now you notice too, these are two different diameters at the bottom. So this telescope can do a 2-inch or an 1.25 inches. But since most of my eyepieces are an 1.25 inches, I like to find what I'm looking at with this one. It's a nice, relatively wide field of view, and I think it's around, it's probably around 60 or 70 magnification. And then once I find it, then we start getting into higher power. This is one of my most used eyepieces. This gets me in the high 80s, like 87.
Yeah.
And you're like, well, that's not real high. But a lot of things are so diffuse and dim that if you get high magnification, they just get dimmer.
Yeah.
So there's a rule here that the higher magnification, the dimmer the image. The lower the magnification, the brighter the image. So because it's like we're focusing in and we're not getting the same amount of light when we get higher magnification.
Okay.
Now for planets, we start here at 120, but that's just where we start. It doesn't get fun at 120.
No.
It gets fun when we get down here at about 214, This is a 7mm. This is one of my favorite eyepieces.
Is that what you were using to see Jupiter the other night? Okay.
So 214 for me is where you start with Jupiter.
Okay.
That's the start.
Oh.
So that
Oh man.
right.
I wish I could have been there.
Oh, it's beautiful. Well, we didn't get to last night either,
Oh,
so don't.
yeah.
I mean, it's you gotta have a clear night. But
Yeah.
these little Teleview eyepieces are great. So that's there, and then we can go to here. This is about 304.
Okay.
Now I've got some steps though in between 214 and 304, and that's what I use these for. These are called Barlow lenses. So all these do is take a magnification and multiply it by 2. See, it says 2 times Barlow right
Okay.
there. Or you can get a 3 times Barlow. So all that does is it takes your magnification and multiplies it. So I can go here
Yeah.
at 120, multiply that by 2.
Yeah.
So this just fits
Oh,
in there.
wow.
And then that goes in the eyepiece like as an assembly. And I'm at 240. So I've got a step between 214 and 304. And then of course I can go higher than that, which I do.
Okay. Oh.
So a lot of fun is to, let's say, to take the 12, maybe put the 3 on it.
Yeah.
You're working with something between, like again, you're 360, 370. That's a good number for Saturn, is over 300 magnification.
Okay.
Saturn can handle it. We use these little tools to align the mirrors of the telescope. This is that one works the old-fashioned way. This is a laser that I stick in the eyepiece and helps me align the mirror.
Now,
And then
can you
some-
take pictures of everything you're seeing and put it in your computer?
Well,
Since it's hooked up to your computer?
You can, but some telescopes are better at that than others. So mine is not great.
Oh.
To do photography well, you want an equatorial mount. And that's a mount that literally is moving the same way the sky is moving. So you align it to the North Star, and the telescope just tracks like the sky
Yeah.
does. This works, again, like, I don't have the base on it, but it's like a big lazy Susan down there when I put the big circle base
Yeah.
on. And then this up and down motion. So my telescope very smoothly, but it tracks like this.
Oh.
But it does it so smooth that if you're just visually observing, you'll never know.
But if you take a picture, you
Long
know.
exposure photography,
Oh.
this isn't the mount that you
I
want.
see.
Now, a lot of cameras today, Ellen, you can use your phone, attach it to an eyepiece,
Oh, really?
and take 100 short pictures
Yeah.
and stack them together.
Oh, wow.
So you can do moon and planet photography pretty well,
Okay.
but long exposure, nebula and galaxies, this isn't what you want.
And you do have a sleeve you put on here too.
Yes, to
But
keep
you,
out all of the little light scatter.
and-
So it's kind of an elastic cloth material. It just slides over the top and
Okay.
encloses the whole thing. So yeah, the light path comes through, eyepiece goes in there. I'll put one in just so that you can.
and this
Get
is
the idea.
the brand is Orion. It's not Celestron, but you have some of the lenses are Celestron.
Yeah, I
They're
have some
compatible?
Celest. Everything's compatible.
Okay.
I like some of the Celestron eyepieces.
Yeah.
So the eyepiece goes in there, you screw it in tight, and if you go right here, Ellen, you can your camera's probably going to pick up that little reflection in there.
Oh yeah.
Yeah. So that's what's going on. And so that light path that was converging to a point finally focuses to one point right about there where your eye goes.
Right.
And then here's your focus knobs
Okay.
to help you see the eyepiece move in and out. That's our coarse focus. This is our fine focus right here. This little knob, that's the little tiny movements for when you're really dialing it in.
Yeah.
And so that's just, again, that light path is coming to one point, that big cone to one point. And this just helps us get our eye to where that point is focusing and where our eye wants it to focus, because our eyes work differently. So as you
Okay,
can see, I
yeah.
wear glasses.
Yeah, me too.
So all of my eyepieces,
Oh,
I have to use the ones that do
look
this.
at that. Okay.
That way my glass lens
Yes.
can get very
Doesn't get in the
close
way.
and it'll focus and I can see the whole
Oh.
field of view.
Otherwise, you'd have to take your glasses off.
And then it's like looking down a tunnel.
Yeah.
So, if you can take your glasses off, and that's fine if you're nearsighted or farsighted, because a focus will fix that. But if you have astigmatism, you're not going to
not
get
gonna
you're not
work.
going to get a focus.
Oh, that's good
so
to know.
I have astigmatism, a relatively strong one. So I use my glasses,
Okay.
and every eyepiece I buy
Has to have
has to
that.
have the
Good to
fold down
know.
eye cup
Okay.
and something we call eye relief. I need 20 millimeters of eye relief to use my glasses comfortably.
Oh, really?
And that
Okay.
means I'm limited to only a few different kinds of eyepieces.
Wow.
Many eyepieces, the eye relief is 10
Yeah.
millimeters, 12
Uh-huh.
millimeters.
Okay.
I can use it, but I'll never see the whole field of view. It'll be like looking like down a tunnel like this. So I have to find ones. That means I pay a little bit more for my
Okay.
eyepieces. It's not for everybody.
A few more conferences and
A few more videos, a few more classes,
books.
right? So, do you have any questions, Ellen, about the way that it works?
Well,
or?
this is what, your 4th or 5th telescope?
This is
right?
number 4.
Number 4.
Yeah, I have owned and sold. My first telescope was a Dobsonian
I remember,
reflector.
yes.
It was not computerized.
Nope.
And it's smaller. It was an 8-inch mirror. This is a 12-inch mirror.
Okay.
A little over 12.25 inches down there. That's your primary objective.
Yeah.
If anyone's interested in telescopes, never pay attention to the magnification. Never buy any of that stuff. The power of a telescope
It's in the
the
size.
size of its primary
Right.
objective.
Okay.
That's all that matters.
That's what matters the
How
most.
much light does it gather
Yeah.
and how well does it focus that light?
And the bigger, the better.
The bigger, the more it's going to resolve, and the brighter the image, which means the dimmer the object you can see. But different telescopes do things differently.
Okay.
So this does a really good job of gathering the light. And I can see tremendous detail on Jupiter and Saturn and Mars.
So a lot depends if you're looking at stars or if you're looking at planets.
Totally. And most people would say this isn't a great telescope.
And maybe
for
where you
planets.
live
Yeah.
too, right? Because if you're west of the Rockies, you can see the Milky Way really well. You might want a totally
This is a
different
great
one.
telescope,
This is
west
a good
of the
one for that.
Rockies.
Okay.
Yeah, so I love the planets the most, and there might have been telescopes that someone would say that'll do better on the planets than this. But really, I just wanted the biggest objective lens, or the biggest primary objective that I could find that would also track the sky, so that I don't have to move it constantly. And that's
Yeah.
good because you don't want to move it if you're
How
looking at the
heavy?
planets. Assembled with the base, it's 125 pounds.
Oh, that's not too bad.
It's not.
Takes
but-
2 people.
But
though.
it comes apart, right?
Uh-huh.
So, this assembly, this tube
Yeah.
is its own thing. These trusses come off, which
Okay.
means this is separate.
Okay.
And then, of course, the circular base, I don't have it on, and that should tell you that it comes off of the circular base. So I've got 1, 2, 3, and then the
4.
base, 4 parts.
Okay.
And the heaviest is probably 40 pounds. So it's very manageable.
But nothing you can bring on a plane. You have to
Can't bring
take it
on
in
a
your
plane.
car.
Yeah, you're gonna have to
Yeah.
have a. But again, when it's broken down, I have a 4-door small compact sedan.
Oh.
And it fits. So it's a giant
The
telescope.
kids have to
that
go in
can-
the trunk though, right?
The kids have to take a different car. But that's how that works. And yeah.
Put the telescope in the car. The kids, you go in the trunk.
So
All right.
there's so many great resources out there, Ellen. I would say anyone that's interested, you should have in your library the book, The Backyard Astronomer's Guide.
We
Terrence
put that
Dickinson,
in the class.
Alan Dyer.
Yes.
It's like the Bible.
It's the standard.
For backyard astronomy.
Okay.
And that tells you all about telescopes and star observing. It's just
Yeah.
it's the
I don't
perfect
have that
companion.
book, but you did point that out in one of the videos
Yeah.
you sent me.
Yeah.
So that's really good. Now that you've bought this, are you happy with your purchase? Are you glad you did it, or do you have your eye on the next one already?
No telescope owner is 100% satisfied. That's why I've owned 4.
Oh yeah.
A lot of people don't sell them. They just keep them. And then they have like a stable of telescopes and they
Yeah.
all do different things the best.
A staple of telescopes.
It's true. I am actually very glad that I purchased this.
Okay.
For this reason, Ellen, I've been observing for decades now.
Yeah.
And the more you look, the more you'll see. If you peek, you just see a little bit.
Yeah.
If you linger and you stay there for 30 minutes or an hour looking at the same thing,
Yeah.
the details come in. You train your eye
eyes.
to see what's there. So I would be out with, say, my wife, and we'd look at Jupiter, and I'd say,
Yeah.
hey, I see 20 different bands of clouds. And
Yeah.
I see this and that. And she would look and go, I just see 4 different, the 2 majors, maybe one on the top, one on
Right.
the bottom. Well, this telescope lets anyone who's never really looked see all the things that I've been saying was there.
Oh.
So even someone that just has peeked,
Yeah.
they'll look through this and they see everything that I'm saying is there. This does a really good job of bringing out the detail.
And it takes your eyes a while to adjust.
Yeah.
And so how do you prepare before you go out? Because you don't want to be looking in a phone or at light. My
Right.
husband used to fly and they had to use far infrared and
Yeah.
lights and stuff. And he said they had to put him in a dark room for 2 hours
Yeah.
to let his
Totally
eyes
true.
adjust.
The general rule is 15 minutes.
Okay.
Will let your pupil dilate. About another 15, because there's a physical dilation, and then there's
Yeah.
actually chemical receptors
Oh.
that get sensitive to
Okay.
to light. They take about another 15 to really work.
So about half an hour at least?
I think a half an hour, your night adjusted vision is working well.
And do you have to go in a dark room or close your eyes, or what do you do?
I think you just factor it in that when you go out at night, 30 minutes later, you're going to see a lot more than you saw when
Okay.
you first went out. But you try not to look at lights. You try not to look at your phone. If you have a light, use a
Yeah.
red filtered light.
I gave my students red cellophane to put over their
That's
phone.
all you need. Red
Okay.
cellophane wrapped pretty thick.
Yeah.
Multiple layers
Oh,
around the flash.
multiple layers.
You,
Oh,
you don't want
okay.
any of the yellow or the white coming through. It should just look like a dull red glow.
Okay.
And that's normally star charts are printed so that they still show up under red light
Okay.
for that reason.
Oh,
Yeah. So
okay.
yeah, that's
All right.
That's it. I tell you,
So-
Ellen, I wish I had another. The funds that bought this, I wish
Yeah.
I doubled it, if only because I'd love to have this, and then I wouldn't mind what they call a cadiotropic telescope. That's it can still be a nice primary objective. It uses a lens and a mirror.
Yeah.
They're called Schmidt-Cassegrains or Maxitov-Cassegrains.
Oh, you talked about that in your video.
I could use a 10-inch or an 11-inch Schmidt-Cassegrain. It'll travel really well.
Okay.
But this is tough to beat.
Yeah.
I can set this up in 15 minutes.
Okay.
I
All
mean,
right.
it's a pretty good deal.
And
Yeah.
the company, Orion, you've had Celestrons too, right? So you don't really
Yes.
have a preference as far as what company?
I've had a Celestron, the first one that was a smaller version of this and not computerized. That was a Celestron. It was sharp. That was a great telescope. Beginner telescope.
Yeah.
You could find an 8-inch Newtonian on a Dob mount for $500.
Oh, wow.
It's a good entry. A little
Okay.
less is a 6-inch, and that may be the most perfect beginner telescope there is.
And none of those you hook up with your computer.
They're
you just
all
find
manual,
everything.
which is the way you
Okay.
should start.
Yes.
You learn the sky that way.
Exactly.
I've had a Meade Maxitov-Cassegrain. That's a real compact design. Pretty good for the planets. It was 5 inches.
Okay.
And I was like, I got to go bigger. So then I bought a Russian. I had it imported. There was a
Oh.
Russian company called Intis Micro, and
Yeah.
they made Maxitov-Cassegrains really good on the planets. It was 6.5-inch primary
Wow.
objective, and that was a good instrument.
Yeah.
I wish I still had that one. It'd travel great too.
Yeah.
But they all have their pros and cons. That one had to cool down, so
Oh.
the mirror and lens would flex.
Oh.
Needed an hour and a half outside to adjust to the temperature.
Wow.
This doesn't need that.
Okay.
So that had its pros and cons. I sold that one, and this is number 4. So I've had Meade, Celestron, Intis Micro, and Orion.
Okay.
I don't have anything bad to say about this. This
And
is
what's good too is the lenses can switch out. You can use any lens from any company.
That's correct. The only thing that matters is it an inch and a quarter, or is it a 2-inch?
Yep, I see that.
So this can
So
come out.
either one.
So a 2-inch eyepiece can go in there, which is about the diameter of that.
About.
So there are inch and a quarter. Never buy eyepieces that are less than an inch and a quarter. Telescopes that use 0.925 diameter eyepieces are a thing of the past.
Okay.
So inch and a quarter is the standard. 2 inches is like kind of the step up, and I think now they're making even like 3-inch eyepieces. But
So if you
I don't have
find a
use for
used
that.
one somewhere and it's too small, it's not worth it. You wouldn't be able to buy more lenses that would be compatible.
That's correct. And honestly, I would tell people, if you're looking for that first telescope, try not to go less than 6 inches in the primary objective, and that
Okay.
normally means a Newtonian.
Okay. And about how much money would that be?
If you did a simple mount, not computerized, not motorized,
Yeah.
you move it around manually. A 6-inch mirror at the bottom, so this design, just smaller. $400, $350.
Okay, that's
Used $200.
doable.
And they're typically pretty good quality. Celestron, Meade, there's a Star. I won't be able to think of it now, but there's standard models. They're pretty much all made in the same place, just packaged differently.
Okay.
And it may be the most perfect beginner telescope there is a
Okay.
6-inch Newtonian or an 8-inch Newtonian.
Okay. That's
Yeah.
good to know. I will tell my students that.
Yeah.
Well, thank you, Chris. I really appreciate it.
You're welcome.
We've had a
To
great
everyone that's
weekend.
watching, yeah.
All right. Well, thanks a lot.
Yep.
Okay.
Bye-bye.